Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. There are three different formats of quadratics and each has its own benefits and advantages. So let's start today's lecture about sketching curves based upon quadratics. So when we look at the syllabus of section 2, out of the 9 topics, second one is reserved for algebra and graphs, and the subtopic is 2.11, that is sketching curves. In sketching curves, let's focus on quadratics. And what else is related with quadratics? We are focusing on the knowledge of turning points, vertical and horizontal asymptotes, but that's not needed for quadratics. We are interested in roots and we are interested in summary. And we have earlier talked about finding turning point of quadratics by completing the square method may be required. So that thing is already done, but we will use this particular format over here. Now, first of all, the general form of the quadratic equation. Y is equals to ax square plus bx plus c. There is an x squared term, there is an x term, there is a constant term. It's necessary that x squared term should be there because it decides whether an expression is that of quadratic or not. Now this is the coefficient of x squared, and if a is positive, which I can write as a is greater than 0, that means the shape of the graph is like this. If a is negative, which also means a is less than 0, then the graph shape is upside down. So this is a happy face graph, this is a sad face graph. This graph is that of a minimum point, because there is one turning point over here. So we use the term turning point because the graph turns at this point. So it could be a minima, it could be a maxima. And what is the usage of this particular format? We use it for the quadratic formula. That is one thing that we do. And we also use it for sketching. So let's get started with the basic idea. So sketch of quadratics, let's get started with fx is equals to x squared. So let me get rid my red marker ready. So therefore, first of all, let me draw this y is equals to x squared like this. Let me grab it, touch this point, and in black color, I'm marking the turning point. So this turning point over here, that is the origin. So fx is equals to x squared. And let's go very, very easily on this one. When x is positive, x squared is positive, therefore fx or y is positive. So it lies in the first quadrant. When x is 0, y is 0. When x is negative, x squared is positive, therefore y is positive. So therefore the graph lies in the first and the second quadrant. This is the first quadrant, this is the second quadrant, that's how the graph is. Now this graph is always either positive or it's 0, it's never negative. Let's focus on the graph of fx is equals to negative x squared. Now this negative, what does it do? It reflects the graph of fx is equals to x squared in x-axis. That's one approach. Also, you can see that all these values which are coming out to be positive, they will be reflected down because of the negative sign. So let me use a blue color over here and let me draw a graph like this. So that is the graph of y is equals to x squared. Again, focusing on the turning point. The turning point is still the origin 0, 0. So now this graph could be 0, the fx value could be 0, and it could have negative values. In other words, this graph is never positive. So that is the original one, fx is equals to x squared, and this is the reflected one in x-axis. Now the next thing that I'm doing is that I'm drawing the graph of 2x square. So let's do one thing. Let me copy this thing and let me add a page over here in which I'll just plot this graph without any grid. So this is x square, and let me also copy this one, the blue one, that is negative x square. So let me plot it over here. All good, all clear. Fx is x square, fx is negative x square. So now over here, let me draw this thing again over here. This red one is fx is equals to x square. This blue one is fx is equals to negative x square. And now I'm interested in 2x square. Now if I'm interested in 2x square, so the graph will get steeper towards y-axis. Why will it get steeper towards y-axis? Let's take a very simple example. If I take x is equals to 2, then y is equals to 2 square, that is 4. If I take x is equals to 2, y is equals to 2 times 2 square, that will come out to be 8. That means, let's say over here, if this is x is equals to 2 and this is the corresponding value 2, now I'll be getting a corresponding value. Actually, this 2 is actually 4 and this will be 8. That means the graph will rise sharply. And therefore, let me choose this green color over here. And let me draw the graph like this, more steeper, and let me fit it in like this. So now the turning point is still the same. The turning point for y is equals to 2x square or fx is equals to 2x square, it's still the same, 0, 0, but it's more steeper towards y-axis. In general, I can say if I draw the graph of fx is equals to ax square, and if a is greater than 1, then this is what is bound to happen. It will get more steeper towards y-axis. So take a screenshot, save it, jot it down in your register, and then practice it later. Let's look at the next question, which is fx is half x square. So still, I need this red graph. So let me copy this red graph. Let me paste it over here. And half x square, what will happen? Let's think about it. Let's say I have the value of x is 3. Y is equals to 3 square. I'm simply squaring it. That is 9. If x is 3 and y is half of 3 square, just like this thing over here, what will happen? This is 4.5. That means, let's say if this is 3 and this value is 9, then half of 9 is 4.5. So instead of 9, we have 4.5. Therefore, the height decreases. So in other words, let me use a purple marker and let me write it. If fx is ax square and a is a fraction between 0 and 1, what happens? The graph gets flatter towards x-axis. So now let me draw this flattening thing. So the graph gets flattered towards x-axis, something like this. Got the idea? So let's recap the whole story. So we have this thing which is the original one. The red one is the original one. Let me also mark it. So this is y is equals to fx, or simply let me write this thing as this fx is x square. And this is steeper, fx is 2x square. This red one is the original, fx is equals to x square, and this is fx equals to half x square. So there is this concept of steeper towards y-axis and flatter towards x-axis. Now we are dealing with the negative one. So with the negative one, that is reflection in x-axis, that is reflection in x-axis, but what to do with these two? So now isn't this already drawn on the previous page? That is 2x square. Just flip it. So flip y is equals to 2x square in x-axis. And similarly over here, this is already drawn for you. So flip y is equals to half x square in x-axis. You already know how to draw 2x square. You already know how to draw half x square. So just take this thing down. So now this green one over here, let me copy it. And first it is made steeper and then it's flipped. So now let me flip it like this and let me paste it over here. And similarly over here, let me choose this one, which is the purple one. And let me flip it over here once again like this. And let me put it over here. Now keep in mind, the turning point still is the same. It's unchanged. The turning point is the origin, that is 0, 0. Let me also mark over here 0, 0. So with this stretching and flipping, the turning point is not changing. Got the idea? So flipping, stretching, turning point is not changing. That is some kind of poetry or something. So now this thing is done. Let's talk about x square plus 1. So let me go all the way up and grab the red one, which is x square. So I have grabbed this x square. And this is x square plus 1. So let me first put it over here. What is the next one? That is also x square. Let me put it over here first of all. And then on the next page, it's 2x square. And then this is 2x square. So let me pick the 2x square. That is this one. So I think it's a good idea that let me place the original ones where they belong. And then I can move them around. So this is 2x square. This is 2x square. That is all set. Let me just go over here. Negative 2x square, negative 2x square. So negative 2x square should be just this thing flipped down. So now like this and like this. That is good. Let me copy it and let me copy it over here. So hold for a second. Like this and like this. And let me also focus. No, that is something else. So first of all, over here, when we talk about 2x square, the turning point is 0, 0. So y is equals to 2x square. The turning point is 0, 0. Y is equals to 2x square. Turning point is 0, 0. Over here, y is equals to negative 2x square. Turning point is still 0, 0. Y is equals to negative 2x squared. Turning point is still 0, 0. So let me mark it. Let me mark this thing. Over here, this thing. Over here, this thing that's drawn. So now I'm interested in 2x squared plus 1. So let me choose a red color. And this is 2x squared plus 1. So now over here, if I want to draw this thing, so I should take the same thing, copy it, and then paste it over here like 1 unit up. And it's a good idea to change the color to red. So that is this one, which is y is equals to, or fx equals to 2x squared plus 1. So this is fx equals to 2x squared plus 1. And let me make it thinner because the marker is too thick. So there it is. This is fx is equals to 2x squared plus 1. This is fx is equals to 2x squared. What happens to the turning point? So now the new turning point, that has been increased by 1 in the y direction. That is 0, 1. And similarly, let me just copy this thing. And now it is 2x squared minus 3. So let me shift it 3 units down. This is just approximate. So therefore, the turning point 0, 0 has now been shifted to 0, negative 3. So turning point is now 0, negative 3. That turning point is 0, 1. So this is 0, 0 becoming 0, 1. and 0, 0 becoming 0 comma negative 3. As simple as this. Minus 2x square plus 1. So minus 2x square is already drawn, and let me draw on top of it. So let me just pick this thing up. Okay, now over here, copy and write it and flip it more or less the same size, and this is minus 2x square plus 1, something like this. So therefore the red one, this is fx is equals to minus 2x square plus 1. The turning point is 0 comma 1. This turning point was 0, 0. All good? Also label this fx is equals to x square. Also label this fx is equals to x square. Actually it's 2x square. This is also not x square. This is 2x square. It's already steep. Got the idea? And now the new turning point is 0 comma 1. Over here the new turning point would be what? It is moving 1 unit down, that is 0 comma negative 1. Let me flip it, write it below, something like this. It's not drawn to scale, so this 0, 0 is becoming 0 negative 1. Over here 0, 0 becoming 0 comma 1. So that was all about the basic idea. So let me recap what we have done so far. We were talking about y is equals to ax square plus bx plus c. We were looking at questions in which there was an x term and there was a constant. We talked about that steepening, that steep thing or flattening thing. If y is equals to ax square, if a is greater than 1, it becomes steeper towards our y-axis. It gets flattened towards x-axis. When does this happen? If a lies between 0 and 1. Y is equals to negative of x square. This is a reflection in x-axis. And if we write y is equals to x square plus minus a constant, if it's plus k, it moves up. If it's negative k, it moves down. And this is like a vertical translation. So these kind of basic ideas, do not underestimate them. They do ask all these things. Now comes the concept of completing square method. A is the same. If A is positive, that's the shape. If A is negative, that's the shape. And now h comma k, that is the coordinate of the turning point, the stationary point. Now remember that this is a gold standard equation, just like y is equals to mx plus cs. So you will always compare with this thing for the turning point. Always compare with this to get the turning point. All good, all clear? So now over here, let me focus on this one. So let me go ahead and write underneath it. That is ax minus h whole square plus k. And when there is nothing on outside of the bracket, there is a 1. So a is 1. It's a positive number. That's how the shape is. Now compare this. Minus h. A lot of people, they are short-sighted and they forget this minus. Negative h is negative 1. Therefore, h is 1. So therefore h is 1 and then k is 4. So just like x comma y, we write h comma k. That's the coordinate of the turning point. So when we talk about this thing, there are two things that we consider. We talk about the shape. It could be this or it could be this. And we talk about the turning point. So that is h comma k. The shape is dependent upon the value of a, the sign of a. The sign of a determines the shape and the turning point is h comma k. So now over here, all I need to do is this, just mark 1 comma 4 realistically. So let me write over here, let me write 1, let me write 4. It's not drawn to scale. And let me draw a nice curve over here, just like this. So that would serve the purpose, something like this. Let me mark this turning point over here. That is 1 comma 4. The shape is already there. As simple as this. Similarly over here, let me write underneath it a x minus h whole square plus k. Again, A is 1. So A is 1, that is positive, that's the shape. Now minus H is minus 1, so H is 1, but this time K is negative 4. So 1 comma negative 4, that's the turning point. Over here the turning point was 1 comma 4. Over here it's 1 comma negative 4. So let me write over here, this is 1 and this is negative 4, just like this. Let me pick the same graph. So copy and let me paste it over here. So that's how the graph looks like, and that is the turning point. So the shape is the same, but the turning point has shifted down. Instead of 1 comma 4, it's 1 comma negative 4. Let me draw some more. Underneath all of it, make a habit of writing ax minus h whole square plus k. Let me just go ahead and write for every one of them. Ax minus h whole square plus k, so that you know that I'm not compromising on the gold standard irrespective of the format that the examiner has written. They would simply change the h and k with something else like p and q or m and n, something like that. So this is so far so good. Okay, so now let's coming back to this. Over here, A is 1. A could be something else also. I deliberately chose 1. A is 1, positive. That's the shape. And over here, minus h is 1. Therefore, h is negative 1. K is 4. Therefore, minus 1 comma 4. That's the coordinate of the turning point. Let me also focus over here. A is 1. That is positive, that's the shape. Minus h is 1, h is negative 1, k is negative 4. Therefore, negative 1, negative 4, that's the coordinate of the turning point. So now what I do is that let me mark 1 comma negative 1 comma 4. So over here it's negative 1, over here it's 4, and over here it's a negative 1, over here it's negative 4. So that is the turning point. You can mark the turning point first and then draw the curve around it. So over here, this is the turning point. Over here, this is the turning point. And I have copied this as it is because the coefficient of x square is positive. So let me take it over here and put it over here. All good. And let me again paste it and like this. Okay. So now let me use my black marker. That is the turning point, that is the turning point. That's how the graph is drawn. Now wait a minute. There is also something which is special in this completed square form, which is special in quadratic. That is, a quadratic equation is symmetrical about the turning point. So now we also have a line of symmetry, and that is very much asked by the examiner, which is x is equals to h. So let me go to each one of them and draw the line of symmetry. So let me choose a green marker and let me make it a bit thinner, and this is the line of symmetry like this. Let me first draw it and then you can have a good look. It's just a coincidence that in all of them it's either 1 or negative 1. Of course, it will depend on the equation. So a vertical line is the line of symmetry. This is the mirror image. It goes over here, goes over here. If I were to fold along this line, this part of the curve would fall exactly on this. So let me write over here, line of symmetry, x is negative 1. Line of symmetry, x is negative 1. Line of symmetry, x is positive 1. Line of symmetry, x is positive 1. That value of x, that is h. So x is equals to h is the line of symmetry. X is equals to h, that is the line of symmetry, which is a vertical line, a line parallel to y-axis. So now this thing is done. Let's look at this one. So over here, a is negative 1. Okay, that means a is less than 0. Therefore, the shape is upside down. Minus h is minus 1, therefore h is 1 and k is 4. So 1 comma 4 is the coordinate of the turning point. Let me also write over here, a is negative 1. So therefore a is less than 0, it's upside down. Minus h is plus 1, h is negative 1, k is positive 4. Negative 1 comma 4, that's the coordinate of the turning point. So 1 comma 4, let me write over here. This is 1, this is 4, that's the turning point. This is negative 1, this is positive 4. Is that the one? Yes. And that's the turning point. Just take care of one thing. What is that one thing? That one thing is it's upside down like this. So let me just copy and let me also paste over here. So this goes exactly like this. And let me just grab this and just put it over here. So now that is the x coordinate, that is the turning point, not just the x coordinate, the turning point. And if I am interested in the line of symmetry, so that's the line of symmetry over here, and that is the line of symmetry over here. So all good, all clear. Now we are coming to the third one, the most important one. Actually, every single one of them is important, but maybe it's my favorite. That is called the factorized form. That means you have drawn factors out of it. So now what happens in this one? Let me choose a nice color. Okay. So now A is still the same. If A is positive, that's the shape. If A is negative, that's the shape. And what else is there? P and Q, they are the x-intercepts. Let me write three names over here. X-intercept, that means y is equals to 0. Let me write over here, they are also known as solution of equation. Because when you make y is equals to 0, you get x is something, this x over here is p, this x over here is q. So that's the solution of equation. And last but not the least, they are also known as roots of equation, which means the x-intercept, which means the solution. So there are three ways of calling these names. So now over here, how do we draw them? We draw them based upon the shape. If A is positive, that's the shape. If A is negative, that's the shape. And the second thing that we focus on are the roots. So basically, we are looking for the x-intercepts. Either you can do comparing coefficient or just make y is equals to 0. That's the easiest thing. So based upon these two things, we will draw these. We will sketch these. So it's all about sketching. So now fx is x minus 1, x minus 3. First thing first. Focus on the coefficient of x squared. Focus on coefficient of x first. X into x will give me x squared. So what will I write? I'll write coefficient of x squared is positive. That's the shape. The second thing is y is equals to 0 or fx is equals to 0. So therefore x minus 1, x minus 3 equals to 0, x is positive 1, x is positive 3. Of course, you can do it by observation also because this is so very, very basic. So the examiner will have no issue with this particular thing. So now we have the coefficient of x squared, we have the roots. So let me draw this time with a green marker over here. So now the graph goes like this. And let me just shift it a bit this way and let me make it a bit thinner. Hold for a second. So let me make it, no, that's a V shape like this. Okay, this one is better. So now black marker, this is 1 and this is 3. So let me mark over here. This is 1, this is 3. That's how the graph is drawn. Very simple. And I'll add something more to it. I'll come back to it in a short while. So now there is a negative sign on the outside. There is a negative sign on the outside. X is positive, but because of the negative sign, I'll write coefficient of x squared is negative, therefore it's upside down. And the next thing that I'll write, y is equals to 0, therefore x is 1 and x is 3. So it's the same as this, but it's upside down. So let me draw it over here. So it goes like this and let me mark it down. This is 1, this is 3, but it's upside down. Now let me focus on one thing. Do you see any symmetry over here? Of course you will see because quadratics, they are symmetrical about turning point, but there is no turning point over here. Well, there is, but we haven't marked it. So now the additional information is x coordinate of turning point, which used to be labeled as h in the completed square format or form. So x coordinate of turning point is the average of the roots. Let me write it over here. X coordinate of turning point is the average of the roots. There are two roots. A quadratic equation has two roots. It's average of the two roots. So therefore over here, x coordinate of turning point is half 1 plus 3, that is 2. Of course, it's the same over here, irrespective of upside down. X coordinate of turning point is half 1 plus 3, which comes out to be 2. So now let me draw that green line over here. Our green color is already used, so let me choose something else. Let me choose an orange color. So therefore, it's not drawn to scale, just like that. Let me shift it a bit like this. That is good enough. And let me draw over here, no, not this thing, something like this. And let me just shift it a little bit over here. So now let me write this as x is equals to 2. That is line of symmetry. And over here, this is also x is equals to 2. That is the line of symmetry. So that is the beauty of quadratics. You can reach the same thing by many different ways. Now this one, x plus 1, x minus 4, the same thing. Now we can do a bit faster. This is x, coefficient of x square is positive, that's the shape. And let me write about the roots. So now x plus 1 equals to 0, x is negative 1, x is positive 4. Yes, you can have two positive roots, two negative roots, a positive and a negative. Over here, this is x, but look at this very carefully. So now over here, coefficient of x square is negative, it's upside down. The roots are still the same. So the roots are x is negative 1, x is positive 4. 4 minus x equals to 0. Therefore, 4 is equals to x, which is the same thing as x is equals to 4. So now the first one is the normal one. A normal means the one with a minimum, and let me choose this green color. So this is minus 1 and positive 4. So minus 1 and positive 4, it goes like this. I'll soon label it. And this is also minus 1 and 4, but it's upside down. So this is minus 1 and 4, it's upside down. Let me choose the black color. So this is negative 1, this is positive 4. This is negative 1, this is positive 4. And if you want to draw the line of symmetry, x coordinate of turning point is half of negative 1 plus 4. 3 over 2, that is 1.5. So let me draw in orange color something like this. Let me draw in orange color something like this. It's not drawn exactly to scale. And let me just shift it like this. This is x is equals to 1.5. This is x is equals to 1.5. That is the line of symmetry. So far so good. Sometimes you do have to factorize yourself. So this is a square minus b square. That is difference of two squares, which is a plus b, a minus b. So I can write this thing as x plus 2, x minus 2, and then sketch it. But wait a minute. Didn't we just learn from the idea of basics that we can draw the graph of x square? Let me draw it first. So let me draw the graph of x square like this. And it goes like this. And let me copy this. Let me shift it down. So by 4 units, something like this. Yes, you can also do this. Let me change. No, I don't need the screenshot. Thank you. And let me change the color to, let's say, purple. So now over here, this one is y is equals to x square. And this is y is equals to x square minus 4. So this is 0, 0. This becomes 0, negative 4. And don't think that the graph just stops over here. So you can just actually extend this line like this. You can just extend the line like this. That will keep on going. That's not the issue. So there are two ways of drawing this thing. This is one way, that is the coefficient of x square. Let me choose this thing over here. The coefficient of x square is positive, and that's how the graph is. And what are the roots? Y is equals to 0, x is negative 2, x is positive 2. So that's another way of drawing this particular graph. So let me draw it like this. So let me choose this thing, let me draw it like this, let me choose the black color, label it, this is plus 2, this is negative 2. So this is a special example in which one single question was asked in two ways. This is done through factorized form, and this is using the concept of basics plus the vertical translation. That is how this diagram is achieved. All good, all clear? So now I'm a little bit finicky about this thing, so let me draw it again. So let me choose a purple color like this, and let me draw it, and let me just adjust it. So now it looks beautiful. Now what about this one? In this one you have to factorize it. So this is x square minus 2x minus 3x plus 6. So this is an example of middle term breaking, middle term factorization. So let's get started with this. Double check. Yes, it's all good. This is x minus 2 minus 3, x minus 2. Therefore, x minus 2, x minus 3. This is done. Now focus on the coefficient of x square, which you can already see from here. That is positive. That's the shape. What about the roots? Y is equals to 0, x is positive 2, x is positive 3. And let's go ahead and draw this thing. So positive 2, positive 3, something like this. This is 2, this is 3, and then you get the idea. And what else can we do? So just let me give you the example of completing square method. You will get the same answer. Make sure the coefficient of x square is 1. That's the case. Write the first two terms as it is. Push the constant to the side. First add, then subtract square of half the coefficient of x, which is negative 5 over 2, which is negative 5 over 2. Rewrite the first three terms as a perfect square, that is x minus 5 over 2 whole square. Since the middle term is negative, it's of the format a minus b whole square. That is 25 over 4 plus 6, 4 6 are 24. So this is minus 1/4, and this is x minus 5 over 2 whole square. And now let's compare it with ax minus h whole square plus k. A is 1, a is positive, that's the shape. Negative h is negative 5 over 2, so 5 over 2 comma negative 1/4, that is the coordinate of the turning point. So let me just go ahead and draw this thing like this. And let me just push this down a bit. Let me mark few points, that is 5 over 2. And let me just touch this thing, go this way. That's the coordinate minus 1/4. That is the shape. The coefficient of x square gives us the shape. Coefficient of x square is positive. That is the shape and the turning point. Now let's double check. What is the x coordinate of turning point based upon these two roots? That is half of 2 plus 3, which is 5 over 2. What exactly are you getting? The same thing. So I first drew it based upon the factorized form, and then I drew the same graph based upon the completed square form, just to show the versatile nature of this particular chapter, which is called quadratics. And of course you can even double check more by plugging this thing in the original equation. So over here 5 over 2 minus 2, that is negative half. 5 over 2, this is positive half, this is negative half, that is minus 1/4, so that is also confirmed. So therefore we are done with this chapter, which is about quadratics, and we reviewed the three different formats of quadratics and used it to learn a lot of different kind of sketches. Stay tuned for more content on Mathematics with Shahab Yaqub.